Motherboard. The motherboard is the central hub where all other components connect. Think of it as the communication center of the computer. It allows the CPU, memory, storage, and other parts to work together. Often called the heart of the computer, the motherboard comes with circuits and connectors for each component and is typically one of the largest components. It provides ports for USBs, audio, and internet, as well as slots for memory and expansion cards like GPUs. Most motherboards also include BIOS or UEFI firmware, which initializes hardware when you power on the computer. While motherboards vary in size, form factor, and compatibility with processors and RAM, they all serve the same purpose, ensuring smooth communication and power distribution between parts. Even though it's inexpensive relative to other parts, a compatible and high-quality motherboard is essential for a well-functioning system. Central Processing Unit. The CPU, or Central Processing Unit, is the brain of the computer, responsible for executing commands and processing data. It performs the complex calculations required for running applications and system functions. The CPU consists of cores, each acting as a mini processor capable of handling tasks independently, and clock speeds, which determine how fast it processes instructions. Modern CPUs can have multiple cores, allowing for parallel processing and significantly improving performance for multitasking. Though the CPU has minimal storage capacity, its speed in executing mathematical and logical operations makes it the core processing unit. The CPU is housed in a socket on the motherboard and often requires a cooling system due to the heat it generates. Selecting a CPU compatible with the motherboard and suitable for the computer's intended use is crucial for performance, particularly for gaming or intensive tasks like video editing. Hard drive. The hard drive is the primary storage device in traditional computers, responsible for saving all your files, applications, and the operating system. An HDD, hard disk drive, stores data on spinning disks, which read and write information using an arm with a read/write head. Although relatively slow compared to newer storage options, HDDs are known for their high storage capacity at a lower cost, making them ideal for archiving large amounts of data. However, their slower data access time can cause delays when loading programs or transferring files. Most modern systems combine HDDs with faster SSDs, solid-state drives, to balance capacity and speed. HDDs connect to the motherboard through SATA cables, which are slower than the connections used by SSDs. Regular defragmentation is recommended for HDDs to keep them running smoothly, as it organizes fragmented data, reducing search times for the read/write head. Solid-state drive. An SSD, or solid-state drive, is a modern storage device that provides significantly faster data access than traditional hard drives. Unlike HDDs, SSDs have no moving parts, using flash memory to store data, which results in near instantaneous access to files and applications. This speed boost can greatly improve a computer's performance, reducing boot times, speeding up file transfers, and decreasing load times in software. SSDs are more durable than HDDs because they lack mechanical components, making them less susceptible to damage from movement or impact. While they generally have less storage capacity than HDDs at the same price, SSDs have become increasingly popular due to their advantages in speed and durability. SSDs typically connect to the motherboard through SATA or NVMe interfaces, with NVMe SSDs offering the highest data transfer rates. For those prioritizing speed, SSDs are a preferred storage choice. Random Access Memory, RAM, or Random Access Memory, is the short-term memory of a computer, storing data that the CPU needs quick access to while performing tasks. Unlike the hard drive or SSD, RAM temporarily holds information and clears itself whenever the computer powers down. The data stored in RAM allows the CPU to retrieve necessary information faster, as it eliminates the need to access the slower hard drive or SSD continuously. More RAM enables a computer to handle multiple tasks or larger files simultaneously, essential for multitasking and intensive applications. RAM comes in modules, often sticks, that connect to the motherboard and is measured in gigabytes. The amount of RAM significantly impacts performance. Adding more can boost speed in programs that rely on quick data access, such as video editing software or video games. However, RAM doesn't store data permanently, so it should be paired with a suitable storage solution. Graphics card. The graphics card, or GPU, Graphics Processing Unit, is dedicated to rendering images and videos, especially in visually demanding applications like gaming, 3D modeling, and video editing. Unlike the CPU, which handles general processing tasks, the GPU is specifically designed to manage complex calculations related to graphics, deciding which pixels on your screen should light up and in what color. While many CPUs come with integrated graphics that handle basic visual tasks, a discrete, standalone graphics card provides a substantial performance boost for high-resolution displays and 3D graphics. The GPU often has its own memory for quick access to texture and geometry data. The graphics card connects to the motherboard via the PCIe slot and requires a good power supply, as it's power-intensive. A quality GPU is essential for gamers and creative professionals looking for smooth visuals and responsive graphics performance. Power Supply Unit. The Power Supply Unit, PSU, is a critical component that converts electricity from an outlet into the correct form for your computer components to use. It distributes power to the motherboard, CPU, GPU, and storage devices, ensuring each part gets the energy it requires to function efficiently. The PSU's wattage capacity determines its power output. Choosing a PSU with sufficient wattage is vital to support all components, especially if the system includes power-hungry parts like high-end GPUs. Additionally, PSUs come with various efficiency ratings such as 80 PLUS, which indicate how well the PSU converts energy with minimal wastage. A good PSU not only powers the system, but also protects against voltage fluctuations, which could otherwise damage components. Selecting a reliable, properly rated PSU is essential to prevent system instability and ensure a safe, consistent power supply. Computer case. The computer case, sometimes called the chassis, is the enclosure that houses all computer components, providing physical structure and protection. Cases come in various sizes, such as mini tower, mid tower, and full tower, which determine the amount of space available for internal components. The choice of case should depend on the sizes of components like the motherboard, GPU, and cooling system, as well as any future upgrade plans. Additionally, cases are designed for proper airflow and often come with built-in fans to assist in cooling. Many modern cases also offer cable management features, USB ports, and tempered glass panels for a sleek look. While cases don't directly affect a computer's performance, they play a crucial role in heat management and maintaining a neat, organized setup. Choosing a durable, well-ventilated case can significantly extend the life of internal components. Cooling system. A cooling system is vital for maintaining safe temperatures in a computer, especially for components like the CPU and GPU, which generate a substantial amount of heat during use. Without adequate cooling, these parts risk overheating, which can lead to hardware damage, degraded performance, and even system shutdowns. There are two main types of cooling systems: air cooling and liquid cooling. Air cooling is the more affordable and straightforward option, using fans to expel hot air from the case and draw in cooler air. This setup is sufficient for most standard users, providing reliable cooling in an easy-to-maintain form. Liquid cooling, however, is more advanced. It involves circulating a coolant through tubes connected to a radiator, allowing heat to dissipate more efficiently. This method is highly effective, particularly for users who overclock or run intensive applications like gaming and video editing. Advanced cooling setups may also integrate heat pipes, multiple fans, or custom liquid cooling loops for even better temperature management. For high-performance systems, a well-designed cooling system is essential to ensure stability and longevity, allowing components to function at their best without thermal throttling, thereby preserving both performance and hardware life. Wireless card. A wireless card, or Wi-Fi adapter, allows the computer to connect to wireless internet networks without needing an Ethernet cable. installed in a PCI slot on the motherboard or connected via USB. The wireless card uses radio signals to communicate with a Wi-Fi router. Wireless cards are especially useful for laptops and desktops located away from a direct Ethernet connection. They come in different speeds and standards, with newer models supporting Wi-Fi 6 for faster, more stable internet connections. Some wireless cards also support Bluetooth, enabling wireless connections to peripherals like headphones and keyboards. While not necessary for systems near wired connections, a wireless card provides the convenience of mobility and minimizes cable clutter. Upgrading to a newer wireless card can improve internet speeds and reduce latency, especially in a crowded network environment or for high bandwidth activities like streaming or online gaming. If you learned a thing or two from our video, then like this video. Share this video with your family and friends or anyone you think can benefit from it. In future videos, we will be covering a wide variety of topics. If you don't want to miss any important updates, subscribe to our channel and don't forget to turn on the notifications so that you can get notified with our latest videos.